Class 10 Mathematics. I am R.S. Prasad sir. Today your chapter 11, that is the similarity in geometrical shapes. So let us start what will be in your chapter. So first one is the measurement of two similar shapes are in a fixed ratio which is called scale factor. So that one is called scale factor. Second, two polygons having the same number of sides are similar if first, their corresponding angles are equal, and second, their corresponding sides are in the same ratio. Always remember in the ratio. The third one, if a line drawn parallel to one side to a triangle such that it intersects the other two sides at distinct points, then it divides the other two sides in the same ratio. Fourth, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So it is the rules of this chapter. Now fifth, all congruent polygons are also similar. Sixth, the ratio of the parameters of any two similar polygons is the same as the ratio of their corresponding sides of their scale factor. Now, if in two triangles, two angles of one triangle are respectively equal of two angles of the other triangle, then two triangles are similar. It is the property of A similarity creation. Now, eighth one. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are in the same ratio, then the two triangles are similar. That is the SAS, similarity characteristic. Now, ninth one. If in two triangles corresponding sides are in the same ratio, then their corresponding angles are equal and hence the triangles are similar. Now, the last point. The ratio of the area of two similar triangles is equal to the ratio of their corresponding sides. Now come to the exercise. What will be in your exercise? That is exercise first. In the map of the form scale is 1 centimeter is equal to 1 meter. So you have to write 1 centimeter 1 meter. The area of forms is shown as 3 centimeter into 4.4 centimeter. Find out the actual area of the frame. Area on graph. That is the 3 centimeter into 4 centimeter. So actual area is equal to 3 centimeter. That means 3 meter into 4 centimeter, that is the 4 meter, which is 10 into by this scale. It is the scale factor. You can say it is the scale factor. Now multiply to this. So it is the 3 4 12 meter square, and that will be your answer. Now come to the second. You have a square shape painting area. That is the 3600 square centimeter. So you can write here area of square. It is given as 3600 centimeter square. We will take a scale of factor 0.1. So you can write here scale factor. It is your scale factor that is given as 0.1. Find the measure of the one side after scaling the painting. So first of all, we can write the side of square is equal to square root of 360, and that will be equal to 60 centimeter. Now side after scaling is equal to 60 into 0.1. So this will be your 6 centimeter, and that will be your answer. Now come to the third question. In city map, the distance between the railway stations and the airport is given as 3 centimeters. If the scale map is 2 centimeter, scale of map is 2 centimeter raised to 7 kilometer. So 2 centimeter raised to 7 kilometer. Then find out the real distance of airport. So you can say here it is the scale factor is equal to 7 by 2 kilometers. So now you can write here the distance. You have to write distance is equal to 3 centimeters. So we can write here actual distance is equal to 3 into multiplied to this. It is the 3 into 7 by 2 kilometers. So you have to write 3 7 ja 21 by 2. So you can write here 2 1 ja 2. So 0.5. So 10.5 kilometer, and that is your answer. Now come to this theorem. It is a theorem for the next exercise. If we draw a line parallel which is inside the triangle and intersect other two sides at different points, then this line divides these two lines in the same ratio. That means given what is given in triangle ABC. In triangle ABC, DE parallel to BC is given. And to prove, what will be to prove? It is AD upon DB is equal to AE upon AC. Now construction. What is the construction? First of all, draw EN perpendicular on AB. Once again draw. Here is the DM perpendicular on AE and join BE and DC. Now we can take these triangles, similar triangle of this one, and then now we can prove. So let us see the on next page. Let us start. So first of all, area of triangle ADE upon area of triangle BED. You can say BED. It is the half base into height. Base is AD and height is EN. And here is also triangle BED. So it is the half and the base is BD into height is EN. As you know, EN will be cancelled out and this will be also cancelled out. So area of triangle ADE upon area of triangle BED is equal to AD upon BD. So that one is your equation first. Similarly, we can say area of triangle which one? ADE upon area of this one DEC. Triangle, you can say CDE is equal to, we can say it is AE upon EC. So that one is your equation. In the same parallel lines, on same base, all the area of triangles are equal. Between parallel lines on same base, the area of all the triangles are equal. So we have to write this one. So area of triangle, which one? CDE is equal to area of triangle, which one? BED. It is your equation third, so you can write by equation first, second and third. So we have to write which one? AD upon DB is equal to AE upon EC. So you have to prove this one, and it is very necessary and very important. So you have to write in your copy. Let us see the next example one. If a line intersects sides AB and AC of triangle ABC at point D and E. You can see here D and E. This one the D and it is your E respectively, and is parallel to BC, and this one is the parallel to BC. Then prove that AD upon AB is equal to AE upon BC. Let us start how can so. So you have to write in triangle ABC, which one? DE parallel to BC. Then by thals theorem, so it is the AD upon BD is equal to AE upon EC by theorem, which is proved here. Now let us see which is proved. So that one is the proof, AD upon AB. So AD upon AB. Now reversing this one, so we had to write BD upon AD is equal to EC upon AE. So you can write here adding 1 on both sides. So it will be BD upon AD plus 1 and is equal to EC upon AE plus 1. Now their LCM, taking LCM, so AD here is BD plus AD is equal to, here is AE, LCM is AE and EC plus AE. As you know, BD plus AD, it is the BD plus AD, that is the AB. So you have to write here, this one is AB upon AD and is equal to here EC plus AE, you can say EC plus AE, that is the AC. So you have to write here AC upon AE. Now reverse this one. So we have to write AD upon AB is equal to AE upon AC and hence proved. It is very important and that's one the very easy. Now come to the example 2. What will be happen in this? Here is the QRST, a trapezium. It is given that QRST. This one is trapezium in which the QR parallel to S. That is on the QR parallel to S. ST, this one. Yes. And point E and F are located on the non-parallel sides TQ and RS in such manner EF is parallel to side QR. EF parallel to side QR. Okay. Now show that QE upon ET. QE, where is QE? It is the QE upon ET is equal to RF upon FS. Let us start how can do this. Yes, in triangle, which one? In triangle QTS. QTS. What will be happen in? So EG parallel to TS, hence QE upon ET will be equal to QG upon GS. So your equation first. But in triangle SQR, here is GF is parallel to QR. So you have to write here that is the R RF upon Fs is equal to Qg upon Gs. It is your equation second. By equation first and second. By equation first and second, you have to see the right hand side is equal, so left hand side is also equal. So QE upon ET will be equal to RF upon Fs, and hence proved. So you can write this one. Now come to the exercise 2. The radius of a circular field is 52 meter. Draw the map of the field on paper in which the scale is 13 raised to 1 centimeter. What is the radius of the field on the map on paper? So you have to write this one 52 meter. A circular field is 52 radius. It is capital R is 52 meter. And the scale factor is given as 1 by 13, 1 centimeter to 13 meter. It is a 1 by 13. So now on map, radius of circle, it's equal to 52 into 1 by 13 centimeter. So 13 1 ja 13 and 13 4 ja 52. So it is the 4 centimeter, and that will be your answer. Now come to the second. The measurement of two corresponding sides of any rectangle are 5 centimeter and 7.5 centimeter. Calculate the area and length of the side new rectangle formed by the taking new scale factor. So first one is the, now length is given as 5 centimeter, and the first part scale factor is equal to, that is the 0.8. It is length, and the breadth is also given. Breadth is given as 7.5 centimeter. So you can write new length. New length is 5 into 0.8. So you can say it is a 4.0 centimeter. And new breadth, it is the 7.5 into 0.8. Now multiply 8 5 ja 40 and 8 7 ja 56. 8 7 ja 56 and 4, that is the 60, and so 6 centimeter. So that one is the answer. You can see here the new rectangle form is taking new scale. The scale is taken as factor 1, taken with the new rectangle form is congruent to original figure. So let us see here area. Area of new rectangle is equal to length into breadth. So we can write here 4.0 into 6.0. It is 24 centimeter square. So that will be your answer. Now you can do the second part of this question, and that is the scale factor is given here. Scale factor is given as 1.4. So new length is what will happen? It is the 5 into 1.2. It is the, not 12 5 ja 60. So it will be 6 centimeter. And the breadth, it will be your breadth is given as 7.5 into 12 1.2. So you can multiply it to find this length. It will be 9 centimeters. Now the area is equal to L into B, so it is the 6.0 into 9.0. So we get 9 6 ja 54 centimeters square. That will be your answer. And now third you can do, and that is the homework. So you can do at home. It is the very similar to that, the same length and same breadth. So that scale is 1. Now come to the next question. It is the third. In the figure, this one MN is the parallel, this one MN is given as parallel. To find the value of the following, Tn upon Nr. Where is Tn? It is Tn upon N. So let us see what will be happen. In triangle RST, as you know, MN is parallel to ST. So what will be happen? We can say by the theorem, Rm upon Ms will be equal to Rn upon Nt. Put the value. So Rm is given as, it is the Rm is given as 6 centimeters. So you have to write Rm is equal to 6, and the Ms it is 3. So you have to write here 6 upon 3. It is the Rn upon Nt. Now 6 1 ja 6 and 6 2 ja 3 2 ja 6. Now here this 2 upon 1 is equal to Rn upon Nt. Now here is, we can say Nt upon Rn will be equal to 1 upon 2, and that will be your answer. Now let us see the next one. Same, this one is the same figure, but it is given as 6 and 3. So Tr upon Nr. So Tr upon Nr. So how can find this one? So first of all, we can say Mn parallel to St. You can write here in triangle RST. So apply the formula. That will be Rm upon Ms will be equal to Rn upon Nt. Now you can put the value. So you can say here Rm is the 6 and it is 3. So it is Rn upon Nt. Now 3 1 ja 3, 3 2 ja 6. So you can write here Nt. It is the Nt upon Nr will be equal to 1 by 2. Adding 1 on both sides. Now let us add here. So it is the Nt upon Nr is equal to 1 by 2. So add 1 on both sides. Now taking the LCM, it is Nr, and here is Nt plus Nr is equal to LCM is 2. So 1 plus 2. So we have to write Nt plus Nr. You can see here Nt plus Nr, that is the Rt. So you can write here Rt or Tr. So Tr upon Nr will be equal to 3 by 2. So you have to write just opposite this one. No, it is like that. So that will be your answer. So you can see here this one same. Now come to the third part of this question. Nt upon Rt. Nt, this one the Nt and Rt. Here is the Rt. In triangle RST, here is Mn parallel to St. Now you can write here, it is the R M upon Ms will be equal to Rn upon Nt. Nt or Tn both are the same. Now put the value, it is 6 upon 3 will be equal to Rn upon N3. Now 6 1 just 3 1 just 3, 3 2 just 2. You can say 2 is equal to Rn upon N3. Now adding 1 on both sides. Yes, we can add here. It is 2 plus 1 and here is Rn upon Nt plus 1. It becomes 3 and here is the taking LCM, it is Nt and here is Rn plus Nt. So 3 will be equal to, it is the Rn plus Nt, that is the Rt. So you have to write Rt upon Nt. Now just reverse this one. So it is the Nt upon Rt will be equal to 1 by 3 and that will be your answer. Now come to this one, fourth question. By using the basic property of the theorem, prove that the line which is drawn from the midpoint of the sides triangle parallel to the another sides bisect the remaining side. So you can see in this figure, in triangle, which one? This one. This is BEA. In triangle BEA. So what will happen in this? So you can say this one, DF parallel to AE. So DF parallel to AE. So that means BD upon DA will be equal to BF upon FE. But D is midpoint of AB such that BD is equal to AD. So you can write here AD upon AD is equal to BF upon FB. BF upon FE, not FB. Now AD will be cancelled out, so we can say it is BF is equal to FE. So it's your equation first. Now similarly, you can say DE parallel to AC. So what will be upon BD upon DA is equal to BE upon EC. So BD is equal to AD. So you can write here AD upon DAD is equal to BE upon EC. So both are cancelled out. So you can say it is BE is equal to EC. So that will be your equation second. Now come to the question number 5. It is given that DF parallel to AE and DE parallel to AC, then prove that BF upon FE is equal to BE upon EC. Let us start. First of all, you can see in this triangle ABE. Now in triangle ABE, this one. So in this is the DF is parallel to AE. So you have to write DF parallel to AE. So by basic property theorem, so you have to write AD, it is BD upon DA will be equal to BF upon FE. So this one is equation first. Now in second, you can see here this DE in triangle which one? ABC. Which one? DE parallel to AC. So you can write here BD upon DA will be equal to BE upon EC. So equation second. So by equation first and second, what will be happen? The left hand side both having the equal side. So you can write here right hand side are also equal. So by equation first and second, so you can write here BF upon EFE will be equal to BE upon EC, and hence proof. Now come to this question. In this figure, E and F are the located on side PQ and PR. PQ and PR respectively. Then for the given conditions, find out the whether EF parallel to QR. EF parallel to QR. Yes, let us start here. If P is equal to Q is equal to this one and this one. So let us start first part. Now find the value of PE upon EQ. So PE upon EQ. Now put the value P is given as 3.9 and it is 3. So 3 1 ja 3 and 3 3 ja 9. So you can say here PE upon EQ is equal to 1.2. So that one is equation first. Now find the PF upon FR. So PF is given as 3.6 and it is 2.4. Now remove the decimal. So 12 2ja and 12 3ja. So it is the 3 by 2. So you have to write 1.5. So here is PF upon FR is equal to 1.5. So that one is the equation second and this one is the equation first. So by equation first and second, what will be happen? It is PE upon EQ does not equal to PF upon FR. So EF is not parallel to QR. Let us see the second part in this question. So first of all, you can write here that is the PE upon QE. So PE is given as 4. So you have to see here QE is 4.5. Now remove the decimal and put the 0. So 5 9 ja and 5 8 ja. So we get here 8 upon 9. So you can write here PE upon QE will be equal to 8 upon 9 and that one equation is first. Now come to the find the PF upon FR. Now put the value FR. PF is given as 8 centimeters and FR is 9 centimeters. So that is the equation second. So by equation first and second, we can say the both the right hand side are equal. So left hand side is also equal. So PF PE upon QE is equal to PF upon FR. That means EF is parallel to QR and that one is your answer. Now come to the yes, in this question you can find the PE. Here is PQ and PR. PQ and PR. You can see here PQ and PR. Now find out the PE upon PQ. PE is, where is PE? It is PE, so you can write here 0.18 and here is PQ, so you can write it is 1.28. Now remove this one. So 2 9 ja 18 and 2 6 ja 12 and 2 4 ja 8. So you have to write 9 upon 64. So here is PE upon PQ will be equal to 9 upon 64 and that is the equation first. Now PF upon PR. PF is given as 0.36, it is given here, and now the PR is given as 2.56, so you have to write 2.56. Now remove the decimal and divide by 2. So 2 1 ja 2 and 2 2 ja 4 and 2 8 ja 16. And here is 2 1 ja 2 and 2 8 ja 16. Now 2 9 ja and here is 2 6 ja 12 and 2 4 ja. So it will be gives PF upon PR will be equal to 9 upon 64. So that will be your equation second. So by equation first and second, we have to see here what will be upon. It is the PE upon PQ will be equal to PF upon PR. So that means EF parallel to QR, and that will be your answer. Now come to the seventh question. In figure 12.3, it is given as 12.3. So first of all, DE parallel to OQ. DE parallel to OQ. So you can say in triangle, which one? PQO. DE parallel to OQ. That means DE parallel to OQ. That means PE upon EQ. So you can write here PE upon EQ will be equal to PD upon DO. So you have to write PD upon DO, and that is the equation first. Now in second DF parallel to OR. So here is DF parallel to OR. So you can say in triangle, that is the POR. So here is DF parallel to OR. That means PF upon FR will be equal to PD upon DO. So that is the equation second. So by equation first and second, what will be upon? The right hand side are equal, so we can write here left hand side is also equal. So that means you can write here. So that is the PE upon EQ will be equal to PF upon FR. And it so hence this one EF parallel to QR. Hence proved. Now come to the last question of this exercise. In the figure, this one the 12 this one the 12 The point A, B, C are the located these points. So you can say especially the OP and OQ and OR in such a way that AB parallel to PQ and AC parallel to PR, so that the BC parallel to QR. So first of all, AB parallel to PQ, AB parallel to PQ. So you can say in triangle OPQ, in triangle OPQ, what will be happen? AB parallel to PQ. It is given AB parallel to PQ. So we can write here OA upon AP. OA upon AP will be equal to OB upon BQ. So it's your equation first. Now AC parallel to PR. Where is AC? AC parallel to PR. So you have to write this one in triangle OPR. Given that AC parallel to PR, that means OA upon PA, or you can say AP is equal to OA upon AP is equal to OC upon CR. OC upon CR. So it's your equation second. So by equation first and second, you have to see the left hand side of this one is equal to So we can say right hand side is also equal. So OB upon BQ. OB upon BQ is equal to OC upon CR. That means OB upon BQ is equal to OC upon CR. That means BC is parallel to QR. Hence, BC parallel to QR. So it's proved. So एक्सरसाइज बच्चों समाप्त हो रही है। नीचे लाल रंग का बटन दिखाई दे रहा है, इसको दबा के सब्सक्राइब करेंगे और ज्यादा से ज्यादा बच्चों को शेयर करेंगे जिससे ज्यादा बच्चों को फायदा हो सके, और मेरे वीडियो को लाइक भी करेंगे जिससे मुझे पता चल सके आप लोग इसको देख रहे हैं और अच्छा लग रहा है, मैं आगे और बनाने की कोशिश करूंगा। थैंक यू, हैव अ नाइस डे। इसी के साथ मैं आदर्श प्रसाद सर इस वीडियो को यहीं समाप्त करता हूँ।